Hello guys, my name is Navraj Saha, and today in this lecture we will learn about series and a parallel circuit, and also learn how we can calculate current, resistance, voltage, also known as potential difference, and power in those circuits. But before we start the calculation, let's start this tutorial with the introduction of current, resistance, and voltage. Let's take a look at the circuit. This circuit contains voltage from battery and two resistors. Now, in order to flow current in this circuit must contain potential difference. Now, what is potential difference? If you consider A and B are two terminals in the circuit, and a terminal A has some voltage and also terminal B has some voltage, then the result after we subtract those voltage called potential difference between terminal A and terminal B. If the potential difference between A and B is 0, then no current will flow from A to B. But if the potential difference is not 0, it has some value, then depending on value, it will either flow from A to B or it will flow from B to A. Now, how we can maintain those potential difference? It's simple, just by adding a battery or a cell. As you know, a battery has two terminals, a positive terminal and a negative terminal. So I took this symbol which is used to denote battery and redraw it here, where the positive terminal of the battery is denoted by the big line and the negative terminal of the battery is denoted by the small line. And we consider that the current flows from positive terminal through the circuit to the negative terminal. In short, current flows from positive terminal to the negative terminal. But electron flows just opposite direction of the current flows. It flows from negative terminal to the positive terminal. After that, what is current? Current is the amount of charge passes through some point. So if I want to calculate how much current passes through a point A, then I just have to calculate how much charge passes through a point A in a single second. At last, what is resistance? Resistance is the property of a material that reduces current flow through it. That means if the resistance of the circuit is high, then the current flow through that circuit is low. And if the resistance of that circuit is low, then the current flow through that circuit is high. After that, let's jump into series and parallel circuit. In this circuit, two resistors are connected in series connection. And the way to find out series circuit is quite simple. If a current have to flow from terminal A to terminal B, and we know in this circuit current flow in a clockwise direction, so to flow current from terminal A to terminal B, here current has only one path, that is this path. So if the current has only one path, then we call that circuit a series circuit. In other hand, if you look at this circuit, if a current want to travel from a terminal A to terminal B, it can flow through this path through R1 resistor. Also it can flow through this path through R2 resistor. So in this circuit, current has two paths to travel from A to B. That's why it is a parallel circuit. At last, we have this circuit, which is a combination of series and a parallel circuit. If we let the current to flow from A to B, then we see a series combination type. But if we let a current to flow from B to C, we can see it can flow through R2 resistor. Also it can flow through R3 resistor. It shows that current have two paths to travel from B to C. So between B and C, it is parallel type of connection. Now let's do our first problem related to a series circuit. In this series circuit, we have 15 volt of battery, current I flow through the circuit, and two resistor 100 and 50 ohm connected in a series connection. Here we want to calculate the value of I, voltage drop in each resistor, equivalent resistance of a whole circuit, and also the power. Now our first step is to calculate equivalent resistance. We know this is a series circuit, so we can write R is equal to 100 plus 50, because in series circuit we simply add the value of resistance that are in a series connection. It gives us 150 ohm. We can write it here because it is an equivalent resistance of whole circuit. Here we have voltage and equivalent resistance. Now by using this value and the Ohm's law, we can calculate the value of current. We know Ohm's law formula, V equal to IR, where the voltage is 15, current we don't know, and resistance is 150. Then current I is equal to 0.1 ampere. So simply I can write it here, 0.1 ampere. As you know, in series connection, current don't divide due to resistor, but voltage divide. That means this 0.1 ampere of current flows from 100 ohm, also from 50 ohm resistor. Now by using current and resistor, we can calculate how much voltage is dropped in each resistor. Using Ohm's law, V is equal to 0.1 into 100. Here I am calculating voltage for this resistor. We know 0.1 ampere of current flow through 100 ohm resistor. So here I write 0.1 ampere into 100 ohm. And we got 10 volt. This 10 volt is dropped by 100 ohm resistor. So write 10 volt here. In the similar way, we can also calculate voltage drop by 50 ohm resistor. P is equal to 0.1 ampere current into 50 ohm resistor. That gives us 5 volt. That means 5 volt is dropped by 50 ohm resistor. So write it here. Now let's calculate power also. P, try another color, is equal to Pi. We can derive this formula into two more formula by using Ohm's law. We know P is equal to IR into I equals to I square R. This is our second formula. For the last formula, P equals to V into I is equal to V by R equals to V square by R. Now let's calculate how much power is delivered by our battery by using our first formula. We have voltage 15 volt and current 0.1 ampere. So we can write 15 into 0.1, and that gives us 1.5 watt. This 1.5 watt of power is delivered by the battery. Let's also calculate how much power is consumed by this 100 ohm resistor. For that, let's use our second formula. We know that 0.1 ampere of current flows through 100 ohm resistor. So 0.1 square into 100 equals to 1 watt. That means 1 watt of power is consumed by 100 ohm resistor. Let's see how much power is consumed by 50 ohm resistor by using our last formula. Here we have 5 volt, so 5 square by R equals to 25 by 50. It gives us 0.5 watt. That means 0.5 watt of power is consumed by 50 ohm resistor. As we know, in a parallel circuit, current divides but voltage remains same. That means this 10 volt of voltage is for both 20 ohm resistor and 50 ohm resistor. But current I divided into I1 current and I2 current. Now let's calculate how much current flows through 20 ohm resistor. Using Ohm's law, V equals to IR, where V is 10 volt, I we want to find, R 20 ohm. So I equals to 0.5 ampere. In the similar way, let's calculate I2 also. V equal to IR, V 10, I into R 50. Then I equals to 0.2 ampere. As we know, I is divided into I1 and I2, so we can also write I equals to I1 plus I2, or 0.5 plus 0.2 ampere. That gives us 0.7 ampere. We have total current passes through the circuit and total voltage, and by using these two values we can calculate the equivalent resistance of whole circuit. Again, by using Ohm's law, V equal to IR, or R equal to V by I, equals to V is 10, I 0.7, so R is equal to 14.3 ohm. I can write it here, 14.3 ohm. There is also another formula to find equivalent resistance in parallel circuit, that is 1 by R equals to 1 by R1 plus 1 by R2. Here I am using R1 and R2 only because our parallel circuit is made of two resistors. So if our parallel circuit is made of 3 resistors, then we simply add 1 by R3 in our current equation. 1 by 20 plus 1 by 50 equals to 7 by 100. So 1 by R equals to 7 by 100, or R equals to 14.3 ohm. As you can see, it gives same value as before. Now let's calculate how much power is delivered by the battery. Using power formula, P equals to VI, where voltage is 10 volt and current is 0.7 ampere. So 10 into 0.7 equals to 7 watt. That means 7 watt of power is delivered by the battery. Now let's calculate how much power is consumed by a 20 ohm resistor. P equals to I square R. We know that 0.5 ampere of current passes through 20 ohm resistor. So we can write 0.5 square into 20 equals to 5 watt. That means 5 watt of power is consumed by 20 ohm resistor. At last, let's do power calculation for 50 ohm resistor. P equals to V square by R. We know that the potential difference across 50 ohm resistor is 10 volt. So 10 square by 50 equals to 2 watt. 2 watt. As I already said earlier in this video, this circuit is combination of both series and parallel connection. So the way to solve this problem is to simplify the circuit. If we take a look between A and B, we see 20 ohm resistors are in a parallel connection, and the equivalent resistance of this parallel circuit is in a series connection with 10 ohm resistor. So the way to solve this problem, first calculate the equivalent resistance of parallel circuit and replace a parallel circuit with a equivalent resistance. After that it become a series type of problem. Then we can solve it like our first problem. We have a formula for parallel resistance. 1 by R1 equals to 1 by 20 plus 1 by 20 equals to 1 by 10, or R1 equals to 10 ohm. We know these two resistors are in a series connection. So let's use our series formula to calculate equivalent resistance of the whole circuit. R equals to 10 plus 10 equals to 20 ohm. 20 ohm. Now let's calculate the total current. I equals to V by R, where voltage is 10 volt and resistance 20 ohm, equals to 0.5 ampere, and this 0.5 ampere current is total current passes through the circuit. Now calculate how much voltage is dropped across 10 ohm resistor. For that we can use V equal to IR, where current is 0.5 ampere and resistance 10 ohm. That gives us 5 volt. As both are 10 ohm resistor, so we can write 5 volt here too. We can write 5 volt here also, because both are same circuit. Also this 5 volt. Now let's calculate how much power is delivered by this 10 volt of battery. By using power formula, P equal to VI, where the voltage is 10 volt, current 0.5 ampere, that gives us 5 watt. That means 5 watt of power is delivered by the battery. Now calculate how much power is consumed by 10 ohm resistor. by using P equal to V square by R, where the voltage drop across 10 ohm resistor is 5 volt. So we can write 5 square by 10, 2.5 watt. Also calculate how much power is consumed by this 220 ohm resistor. So P equals to, now to calculate power, currently we have two values, 20 ohm and 5 volt. So we can use this formula, 25 by 20, 1.25 watt. 1.25 watt power is consumed by 20 ohm resistor and also by this 20 ohm resistor. Also calculate how much current is passes through 20 ohm resistor. By using our Ohm's law, current become 0.25 ampere. Also 0.25 ampere for this resistor. And this is the end of this lesson. We learn about series and parallel connection of resistor. Also learn how to calculate current, resistance, voltage and power in those circuit. So if you found this video helpful, then please like, share and subscribe.